Okay, so in this video, this will be part 2 of my OS series, and my previous attempt at this part 2 failed since I just didn't have the mic config that set up properly. I had it below my chin, which made it sound really terrible. It was just clipping, so I'm deciding to redo this to restore what it was like before. And I need to remove this instruction table unless I had it in the video in the code. Alright, so I didn't have it. Alright, so I'm gonna be testing this emulated machine. So, emulated machine real quick. Run. Out. Hello. It's messed up because I forgot to put it in a table. Whoops. No, I don't want to change my input language right now. I don't even have another keyboard layout with typing installed right now. But you can see it says hello there. I'll just pause it. And I'll just stop the simulation. Now I'm gonna do a jump instruction. So if op or is equal to JMP, then let's just run this code. So here, if it's jump, then, but we need an instruction number. So for I'm just going to local inst num equals 1. Actually, I'm going to do this while task dot wait do. Then inst num is equal to, not equals to number params, and then local v equals instructions inst num and split and up params. Yeah, let's change the instruction number. Then inst num plus equals 1. But here, if inst num is greater than the number of instructions, then inst num is equal to, gets changed to 1. Then JMP 1. So output hello, and then it'll jump to 1, to instruction 1. So you can see hello, but it's not jumping for some reason. It's not even looping. Print loop instruction number. So it's just being ran. You can see loops 2, but it's not running it. It's not running the jump. Okay, print op should be JMP. Print jump 2, and then params. It should say jump to 1. Yep, but it's not changing it to 1. So here, using instruction underscore num number. Yep, that's matching exact. Maybe it's because it's going here. So it's just directly incrementing it. There we go. Now I can remove this extra debug info. So I don't need to print this anymore. This. To run a program that just outputs the text hello, and then I'll jump back. Call it UNKASM. UNKASM. Just made up. So to the emulated machine, we'll just keep running it and running it and running it and running it. So eventually we'll get to adding a UI. But what I want to do is I want to change this to local so it won't load any of Roblox's servers if I'm doing a team test. And if internet connectivity features will still run, for those that don't have very stable internet that keeps freezing shortly sometimes, there won't be any interruptions. Eventually we'll get to making a virtual hard disk in the emulated machine. So machine MEM is what I'm calling it. And I want to add a new command, which is why I have this sound over here that I made. Just a hum, beep, function, then it won't take anything, script dot beep underscore 500, play. I want to rename this to beep 500. Let me turn off function lock on this laptop. Just function escape. Then 6.67. So that means 500 divided by 6.67 means that this is a 75 hertz home sound. You can hear a sound, but I want to pitch shift this because it's very short. You're just going to go at 3.3. Sounds a bit worse, but it'll be a longer now. And I also want a no-op with the function of nothing, and then it'll just be an end. Then I'm gonna make this code a bit easier to read that I've written for this emulated machine. So here you can see I'll run 3 no-ops, then I'll jump back to instruction 1. So the no-op only takes 1 clock cycle. Actually, the microphone I'm using is on the left of the couch I'm using, but my laptop's in the middle, which is also where I'm talking. It's definitely some range that I'm getting. So you can see it's just printing hello. It's not beeping, since I don't even have a beep. So just say beep. Then I don't know if sounds in starter pack play. Yep, they do. That's actually really fast. You can see how quickly that's beeping. Considering this no-ops, only 3 no-ops. Soon I'll also get to my own file system, which I'll start the design for. So here, I'm gonna go to Notepad, right? And then this is example. Header is what I call it. So it has 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, which is cool. There's also a 1 at the starting bit. Then that's the first byte. Then the next 2 bytes determine how much storage there is. So this is an example for 16 bytes. Say, and then the data starts here, which is stored in raw. Then 0, 1, 1, 0, 1, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 0, 1. Or I'm just putting some cons in here. And then the rest of it is just filled with zeros. This is 6 bytes, 7, 8, 9, 10, 15, 16. So you can see the data there. And then this data will get filled up. I'm thinking I'm gonna have maybe a kilobyte to store. Might have to increase it later. It's all just stored in a local variable, which uses the real computer's RAM, since that's what Roblox uses for variables, and not a hard drive. Which then there could be a way to access the hard drive, maybe, or at least just write to a file. But if they had like file management, which uses an actual computer, then it could, the actual computer's file system, then it could be dangerous. But they could but they could have some limitations, like only to a folder at the highest level. And then there's other limitations too, such as not being able to use more than 5% of hard drive's available space. Right, actually, 1% of the total space. Alright. So I have my file system design in here. So 16 bytes. So that's what the 16 bytes looks like. But then 1 kilobyte is much more. The machine doesn't have any RAM yet. So I'm thinking of adding some other stuff too, which has maybe I don't know. I don't have any ideas yet. Maybe no ideas yet. Or anything. Maybe I'll actually start with the RAM. RAM equals a new table for equals 1 256. Now adding RAM for I equals 1 8 2. Here. E equals table dot equals ram I equals a new table. And then that's all it does. So we'll fill up 256 bytes of RAM that the computer will use. Say rate 1 function address, and then RAM. Wait, hold on. So I want to convert the byte to the bit. Yeah, I want to convert the bit to the byte in bit. So we'll call bit equals 15. Bit equals 1024. 128 byte. We'll call byte is math.floor. Bit divided by 8. Print byte bit underscore. And we'll call bit equals bit underscore equals bit more 8. And here if I did 1027. Alright. Now let's start floor. Now just divide by 8. And res mod 8 equal 1. And read it. RAM function address. Root. Not here. Root. And here. Right one. 214. Then read bit RAM 214. So when I press play, it'll initialize all that RAM. It's messed up. Got messed up. Because I forgot the comma. And I missed that. Alright. I'm gonna real quick stop the beeping. Read bit RAM. Print RAMs. So it'll print that out. This thing's bugging. And then here is right 1 to 14. Hello. Right one. The 2 knots. 2 milliamps. Isn't quite catching it, I think. Should say read bit RAM. One line. Oops, says read bit RAM. Weird. Print B21. Something right down here. It says a 8-bit RAM right there. Bit RAM? Oh, not supposed to be uppercase. That's why. It's lowercasing it. That should be saying ones or maybe ears. Did I need to fix? Oh, no, I'm seeing ones. Here's reading a bit from RAM. Then that match, so it executed it. Alright, so hope you enjoy this video long. I hope you enjoy this really long video. I'm bored.